As we discussed in the previous case, we are having the transformation matrix for transforming a vector which is in the NOA reference plane. So this P, which is in PN, PO, PA, because of the reference frame, because of the frame NOA, we have to find out what is PX, PY, PZ if that frame is having any shift. So if now there is no shift, there is no rotation, this was the matrix that we had told. Now let us look for the second case wherein we are having a rotation with respect to n. That means if I am going to talk about the rotation, let's say it's in this direction, which is, as you correctly know, it is anti-clockwise direction. So if in the anti-clockwise direction we are having a movement, then obviously that angle with which O axis and A axis will move, let us name it as theta. Similarly here also theta. So O and A are shifting with respect to the x and z axis with an angle of theta. So in that case, if there is a vector, just like here we are having P, if there is a vector here, then what is the transformation matrix that we have to rotate, or we have to apply, sorry. For that, so let's write for this particular case, this is rotation of frame with respect to x axis or with respect to n axis. So rotation of frame with respect to x axis. So I will write rotation with respect to x axis. So if I am having rotation with respect to x axis, I will basically write the px. So I will write straight away the matrix. It is px, py, pz. Then I will have the matrix written as, now here you should be careful of what I write here. 1, because I will be writing in short form. So it is 1, 0, 0. The second one is 0 cos theta. Cos theta I will just write it in short form as c theta. Then I am having minus sine theta, which I will write it as minus s theta, minus sine theta. We will write always in short form. So here it is going to be 0 s theta cos theta. Then here we already know that the scaling factor is 0, and the last one, since there is no translation, I will just write 0 0 0 1. This is what we will multiply with our present Pn, Po, Pa and scaling factor of 1. This is rotation with respect to x-axis, and this is the formula that we have to by heart. There is no other option for it. Similarly, in the second case, we can see that the rotation is with respect to y-axis. So the rotation is with respect to y-axis. So if I am going to write like this, so this is, again anti-clockwise. When I look from here, it is going to be anti-clockwise. So I will write here anti-clockwise. So anti-clockwise, I will write the angle, this one as theta, and similarly this one also as theta. In that case, I will get an equation here. Similarly, in the third case, we are having a rotation with respect to z axis, and with respect to z axis, when I am writing, then I will have to write, so I am basically rotating it in this direction. So this is again anti-clockwise direction. So what we'll have is, here we will have an angle of theta. Similarly here also we will have an angle of theta, and based on that we will have an equation. The equation can be written for both the cases as these equations. So as you can see, here again we are having, for rotation with respect to x-axis, we are having c theta, sorry, with respect to y-axis, we are having c theta, which means cos theta, 0, sin theta, 0, 1, 0, minus sin theta, 0, c theta or cos theta. Same way here. So it's actually basically a rearrangement, and this is something that we will have to always remember. Now let me show the short form how it is written. Basically it is written in this form, like let's say that it is p in xyz form, then we are multiplying with a rotation of let me just see this, I have missed something. 1 2 3, no, okay. So rotation, here we are having no rotation, so here it is just the identity matrix multiplied with PNOA. As you can see, there is no rotation here. Whereas here when we are having a rotation with respect to x-axis. As you can see, I have caught n and I have rotated it in anti-clockwise direction. So here we will write Pxyz is a rotation matrix where we have rotated with respect to x an angle of theta. It's not that we have rotated x with theta, we have rotated by with respect to x-axis, we have rotated the frame NOA, and that we have got it as rotation x theta, that multiplied with PNOA. Similarly, for the other cases, we will write Pxyz is equal to rotation with respect to y theta angle multiplied with PNOA, and similarly for the last case we will write Pxyz is equal to rotation with respect to z theta angle into PNOA. And this is how we can actually convert the PNOA vector to Pxyz vector.